Hello to all the analytics and data science lovers listening to this podcast right now. My name is Stephanie Figueredo.
And I am Chris Quadros, and today we are your co-hosts for the Maths podcast, which is brought to you by the King's Econo-Math Society.
Before starting, we would like to extend our special thanks to the research team, Kristen Fang and Amara Awaji, as well as our VP of ADS Relations and Communications, Rajul Jain. Also, honorable mentions to Professors Felipe Rodriguez, Joseph Turnbull, and Tyler Pattenden for working with us to bring you exciting and informative ADS resources after this podcast as well.
So analytics and data science is designed for the students who like to run numbers and solve puzzles, but also are more into management and business. Students will be benefited from the concrete career skills and experiential learning with extensive labs, tutorials, and projects. The interesting thing about the ADS program is that it can be combined with any major module. If these topics that we speak about interest you, please consider reaching out to the School of MEM for more information on how you can enroll. Analytics and data science is the future, and the future is now.
Today, we will be exploring game theory, linear programming, as well as many real-world issues involving politics. And if you stay till the end, which I really hope you do stay, we will have an exciting surprise for you. Rock, paper, scissors is a way of doing chores. Rock beats scissors, scissors beats paper, paper beats rock. You might be asking yourself, what does an elementary game have to do with me and my life? The answer is quite simple. Everything.
As it turns out, we're mostly rational beings and a product of our choices, whether good, bad, or neutral. And if we examine the idea of choices a little closer and reflect back to the start of the pandemic, a pattern emerges within the business realm.
Companies who made the conscious choice or decision to reorganize their strategy and business model to meet the needs of the environment were able to come up on top, flourish, and reap in profits while gaining market share.
On the other hand, companies who did not make the right choices to compromise were left behind, ultimately losing. It is not only in business, but every day we find ourselves asking what's the best option? How do I win? Would working alone or in a group benefit me? These questions are universal and the basis of human nature. We interact with our environments due to resources and scarcity.
We would like to have it all, but we can't. We have to decide. As we see, winning in rock, paper, scissors to get rid of not doing the dishes mirrors our everyday lives when we are faced with different options and have to make the most effective and optimal decision. So how do we increase our chances of winning? How do we know what we choose was the best decision?
These types of questions have intrigued an array of mathematicians, economists, and computer scientists. It wasn't until the 20th century that the applications of games were introduced in real-world situations.
Get this. An American-born Hungarian John von Neumann collaborated with his colleague Oscar Morgenstern to see how the idea of games and their elements can be used in economics, coining the term game theory.
We must establish the definition of what is a game. According to the Collins Dictionary, a game typically involves two or more individuals with a set of rules and criteria with the purpose to win and beat their opponents. Therefore, a game has a number of players, rules, strategy, payoffs, and parties that need to understand how to play.
Now, with that fundamental knowledge, we can see the parallels and applications of games to decision making. We have finite options or choices to make. What are the optimal options or choices, and what strategy will we use to achieve our choice to win or make the best and efficient option or choice, as well as the consequences?
Imagine owning a bakery shop and the competition is fierce. You decide in order to compete in the baking industry, you will lower your prices to get more people through the door and drive up the sales.
Wait, but what if the bakery shop down the street has a similar thought-out lower prices or decides to cater to weddings, Chris? What would you decide? Would you continue to lower prices or keep it the same? Would you go after birthdays? Would you need to realize your payoffs are from the options?
Well, Steph, each option has a value or utility, whether it be dollars or market share. And see if that is the best option or choice, you need to decide in order to receive a higher quality.
Yet, if your rival bakery considers the similar or close choices as you will find that certain choices you decide on will force a stable or equilibrium choice where you and your rival will neither choose an option that influences one another. This idea of an equilibrium was first introduced by mathematician John Nash. Nash's theory of equilibrium proved crucial during the Cold War, where the world faced with severe consequences. Hashtag Big Thanos energy, if you ask me. Equilibrium states that certain choices or decisions could be made that do not exploit each and other parties involved.
In our bake shop, we could choose to keep the same prices and target our own market, and our rival will do the same with theirs, and no one will win or lose. Yet, we must keep in mind that equilibrium is not really that static. It is constantly changing, shifting, and re-emerging as we are all influenced by the environment and choices that surround us.
Similar to the election that just passed us, we can review it in terms of game theory. Politics and game theory are not mutually exclusive. Each party begins with a message and then a campaign to persuade votes with the aim to win the election. Presently, there are 5 main federal represented parties, each with its own platform and followers.
We recently witnessed our latest federal election where the Liberals won a minority government. To model how they expected the trade off for their platform to gain the greatest voter share, we can use game theory principles to model this. Stay tuned for that tutorial being released on how we can model that on an introductory level. Let's examine the prisoner's dilemma, which involves 2 hypothetical rational individuals and how they outweigh their options.
The prisoner's dilemma presents a situation where 2 parties, separated and unable to communicate, must each choose between cooperating with the authorities or not. Each bank robber is faced with the choice to cooperate with his accomplice and remain silent, or to defect from the gang and testify for the prosecution.
So imagine you and your friend are getting interrogated by Detective Jake Peralta from Brooklyn Nine-Nine, and he offers you a sweet deal. Jake deep down knows that there was a more serious crime committed, so he wants a conviction, but has no evidence, so it is up to you and your partner to stay silent. However, if you stay silent, both you and your accomplice will spend 1 year time in prison. If you rat on them, you will get a sweet plea deal and be able to walk free, and your partner in crime will spend 3 years in prison. But your accomplice will be offered the same deal, and remember, you are not able to communicate with one another.
But if you were to both rat on each other, then you both spend 2 years in prison, which is more than if you were to both remain silent, but less if your partner ratted on you first. What would you do? Chris, be honest. What would you do?
Well, I'll be honest, I'm getting out of this mess. I'm going to rat on my friend. Sorry, not sorry.
I don't know, man. What if your friend rats on you? Then you're both stuck there for 2 years. But okay, I'm not going to be committing any crimes with you at least anytime soon.
Okay, noted.
Well, the rational economic person would also ultimately rat on each other and take the 2 years because they would look out for their own interests, while their best possible case would have to just stay silent. Moral of the story, don't commit a crime with Chris. But also don't rob in general, and don't be a snitch. Because as they say, snitches get stitches, or so I've heard.
So now using graphs is a good representation for simple problems like this. But if you really want to solve more complex level situations, we can use something called linear programming.
Wait, what is linear programming?
Wait, you don't know? You don't know what that is?
Yeah, no cap.
No cap. Okay, well, prepare for all these facts I'm about to drop on you.
No printer? All facts? No ink, Chris?
Well, guys, that shows that she's also a comedian.
Yeah, you can catch me on my second podcast, stephcomedian.com.
All right, I'll subscribe. I'll subscribe soon, maybe. Anyway, so it is a mathematical technique used for decision making. It quantifies all the options and helps you narrow down their range to find out the most optimal decision. So for example, I can't count how many times I have been late to my main campus classes throughout my 4 years in undergrad because of the random pit stops and geese that you come across on campus.
Dude, those geese are so bad.
Honestly, yeah, I hate them all. So if you want to really apply this theory, we can use linear programming to evaluate what method of transportation is best. Is it walking, busing, Ubering? The way you can come to an effective conclusion is by really understanding factors such as distance covered, arrival time, expenses to help formulate what is the most efficient method of transportation.
Could we even consider it under factors such as weather? Because I know Canadian winters, oh my goodness, are awful.
8 months out of the year. I think that's a really important variable. I think it all is situational too. You have to take in the external situation, the external environment as well.
So that's why we use linear programming. It can be so customizable. That's amazing.
Exactly. It all just depends on the situation you're in. Now, we're not obviously going to tell you all the secrets. If you do really want to learn more, we recommend you watch the tutorials coming soon, which will be added soon to our YouTube and Instagram.
I would just like to say thank you for joining us on our first Mads podcast. We just made history right here. Although it is now coming to an end, sad, I know, but we really hoped we made your Monday just a little better, a little brighter, and really got your brain juices going.
Professor Turnbull, Professor Rodriguez, and Professor Panton will be releasing their introductory tutorials on how politicians use game theory as well as linear programming to illustrate how shadow pricing affects the price of carbon.
If you are interested in learning more, please check out our other resources linked on the Chem's Instagram, YouTube, and the King's ADS minor course website as well.
And now for the surprise you have all been waiting for. Steph, drum roll, please.
Oh, you know this is my favorite part.
The giveaway opens today for a chance to win a brand new pair of Apple AirPods, perfect for you to listen to our podcast in peace anywhere and anytime. To enter this podcast, you must follow us on Instagram, subscribe to our YouTube channel, and drop a like and comment on the podcast episode as well.
Next episode, we will be interviewing a special guest that we will be revealing to you shortly, as well as diving into the realm of artificial intelligence biases, gender-based data, and women in analytics and data science roles. If you have any topics at all you are interested in, feel free to drop it in the comments below on YouTube or reach out to our Instagram at Chems Club directly.
And that is a wrap. So Stephanie and I just again want to thank you for taking the time to listen to this podcast, and we hope you have a great Monday and a great week.
Mic drop.